Learn about what the guests did before research, how they got involved in academia, and what kind of impact their research can have on you. The AlmaMAC is covering it all from Thursday 12 to 12:30 p.m. on 93.3 CFMU, redefining radio in your community.
Hello, and welcome to the AlmaMAC. I'm your host this week, Adam, and today I'm with a very special and probably the fastest and most fit guest we've had on the show, Billy Bostad.
Oh, you're making me blush.
Welcome to the show.
Yeah.
So, where to begin? I guess you are a PhD student here at McMaster.
Yes.
You are in the Human Performance Lab of the Kinesiology Department?
You got it.
Excellent. So far, so good. And so maybe let's just jump right into the kind of stuff that you do at the Human Performance Lab.
Yeah, so it's an integrative physiology lab looking at exercise and how this affects various physiological systems. So my PhD specifically is on really practical forms of exercise. By now we all know that exercise is good for you, right? But people still don't do it. So what can we do to make it more practical? And that's sort of what my PhD focus is going to be on.
Okay, so it's a mix between what is good for people and how to convince them to do it. So a little bit of psychology in there as well? Or?
Yeah, kind of. Well, not exactly in our lab. We have others in the department that do those things. So there's, opportunity for cool collaborations. But for us, it's more from a physiological standpoint. And the implications are that it's a little bit more practical. So from a physiological perspective, we do really, really small volumes of exercise. So it turns out if you do very small amounts of exercise, but you work really hard, you can get the same benefits, physiological health benefits, as doing longer amounts of exercise. So from a simply physiological perspective, that's really interesting. Mm-hmm. The protocol that we employ is just 3 by 20 seconds, really, really hard, with a bunch of rest in between. So overall, it's about 10 minutes of exercise or a 10-minute time commitment. Only about a minute of hard work. The rest is kind of really easy spinning on a cycle ergometer. And you get the same physiological and health benefits as a 45-minute moderate intensity sort of traditional workout. So if you're going to go for a jog or a moderate intensity spin, then you get the same benefits from this really small amount of work. And like I say, it's only about a minute of hard work that you're doing. So from a physiological perspective, it's interesting how the body can adapt the same to such a small amount compared to a very large volume of exercise. And then, of course, the practical implications are everyone's saying, I don't have enough time to exercise. It's like, well, now you have an option, right?
You kind of don't have an excuse now.
Yeah.
Yeah, that is really cool. I guess you see all these apps and stuff come online. Like I saw this one app where they'll just give you it's like an audiobook. They'll give you the 10-minute summary of all these books. And that just lets you gain the benefit of something that would take you a heck of a long time, but condense it into 10 minutes. And that, I guess that's what you found is possible.
Yeah, it's a good analogy, just taking the important stuff and condensing it. In this case, the important stuff is exercising really hard. So that's the trade-off. If you're going to only work for 1 minute as opposed to 45 minutes, it's got to be hard. So we have participants come in and they say, 3 by 20 seconds, 2 minutes of rest in between, easy peasy. And then you talk to them 10 minutes later and they say, I have to lie down. So the trade-off is you got to work hard, but the cool part is, it takes much less time.
So I can't imagine it being exactly the same, doing a 45-minute long, slow sort of thing versus these short bursts. In terms of like a high-performance athlete or something. So this is a technique that you're looking at for the average person?
Exactly, yeah. And surprisingly, it's fairly new. So athletes have been using interval training forever, for decades, right? We've just thought recently about using it for the general population, and that's where most of the research has been on, the average university student or mom and pa, this really benefits them. Whether this translates to athletics is a little bit different because their training is obviously very different. So that's sort of a future stream of research. If you were to say to somebody, a marathoner, let's use the most extreme example, a marathoner, that if you could exercise for only 20 seconds at a time, just really hard. And you can improve your marathon performance. They'd say you're crazy. There's no way. But this research is suggesting maybe that's possible. Not for an elite marathoner, of course, but this type of training could actually be worked into like a marathoner or a long distance person's plans. And you're actually kind of starting to see that. I follow some triathletes and runners on Instagram, and they're slowly starting to get it. They're starting to work this type of training into their regime, which 5 or 10 years ago would have been insane.
Yeah, it seems counterintuitive. It seems like, I don't know, it's almost like comparing doing weightlifting to doing cardio, in my mind at least. Like these really short sprints, it seems like it would work something completely different than what you would need to do a marathon. But I guess it's all interrelated, it's all connected.
Yeah, and that's kind of what you learn in school, even in early and even some late kinesiology courses, is if you work really hard, like if you sprint for 20 seconds, you're using what they call your anaerobic system. So it's not as taxing on the heart. Whereas if you're doing a 45-minute sort of moderate run, you're using your aerobic system, so you're getting better at that. But the truth is, even in those sprints, you're using a lot of your aerobic system. So you're getting sort of the same health benefits. It's just a different way of getting there.
Okay. So when you're doing these studies, what is sort of the output that you're measuring with these people? I'm sure you have different benchmarks and different tests that you do to see how they've adapted, but is there one that you use consistently to?
Yeah, so I mean, the main measure in exercise physiology is what we call your VO2 max, and maybe more health-oriented people call it your cardiorespiratory fitness. It reflects sort of the integrative ability of the body to work. So it's a very good measure for us to do. That's always the first thing we look at. And the first study that came out and showed that this kind of training improves VO2 max to the same extent as longer traditional moderate training was very interesting. So from there, you kind of move forward and say, oh, well, does it improve exercise performance? Like if somebody does a time trial, like we were talking about with the marathon, will it improve that? My study specifically is looking at sort of the mechanisms behind why VO2 max increases. Typically, it's because your heart just gets better at pumping blood, as opposed to some of the other factors like your muscles at consuming the oxygen. So my most recent study was looking at that. And there's been a bit of controversy with some studies that have looked at low volume research or training.
Sorry, before we go a little bit further, we talked a little bit about VO2 max a couple weeks ago, but can you tell the audience what the V is, what the O and the...
Yeah, so it essentially stands for oxygen consumption,
okay.
The VO2. VO2 max is the maximal amount of oxygen that your body can use. So right now, just sitting here at rest, we're still consuming oxygen, and our body uses this to make energy. It's known as aerobic respiration. Now, when we're working at our maximal capacity, that jumps by 100 times or something crazy. So you're using a lot more oxygen because you have a much bigger energy demand. And there are a few systems that sort of go into VO2 max. There's your ventilatory system, so bringing in oxygen from the atmosphere and putting it to the blood. And then your heart to pump the blood throughout your body, the blood to be able to transport the oxygen, and then your muscles pull it out of the blood and then use it to make energy. So it kind of combines all of these systems.
Okay. So, yeah, I guess very simply, like lung size would be important. How much stuff you can get in there, your how well your blood flows, how well your muscles take it. So it has a big thing. The amount of muscle you have also affects this as well, right? Yep,
all of these things. Okay. The amount of iron in your blood. So if you're anemic, this capacity is reduced. Of all those factors, what we found through decades of research, they've discovered this many years ago, is that what really matters for your VO2 max, and particularly when you're improving your VO2 max, is your cardiac output. So of all those factors I described, your heart gets better at delivering the blood. It's not necessarily that you're getting more mitochondria in your muscle or your lungs are getting bigger. Really, that limiting factor is the ability of your heart to pump the blood and therefore the oxygen to your muscles.
Okay, so that makes sense. I guess when you're doing running and things like this, you're not necessarily making your lungs better at absorbing stuff. That seems like, I guess that makes sense to me, that seems like it would kind of get capped and be sort of constant throughout your life for the most part.
It's interesting that if you have some sort of condition like COPD that would reduce your ability of your lungs to bring in oxygen, that will for sure reduce your aerobic capacity or your VO2 max. Same with if you're anemic, that would also reduce the capacity. But when it comes to exercise-induced improvements, it's really the heart that's king.
Okay, interesting. So yeah, your studies are looking at how high intensity affects and your most recent one, how that is affecting the circulatory improvements.
Mm-hmm.
And that's starting to give me a more intuitive idea of why that would be so effective for even these long distance training type things.
Yeah, it's interesting because, how hard can you possibly work? Does the 1 minute of work equal 45 minutes of lighter work? And actually not really. One thing we measured in our study was something called the rate pressure product, and it's essentially just a measure of how hard the heart's working. So when they perform this exercise, 3 by 20 seconds really hard, we measure this not only during that 20 seconds, but also in those 2-minute rest periods in between, and even after the exercise. And what we've found is that the heart continues to work really hard in between those 2 and 3 bouts of exercise. And even up to 5 minutes after the exercise, your heart's still working really hard to catch up maybe on the demand that was placed on it. So I think that's where these adaptations are coming from, not necessarily during that 20-second hard bout, but because those 20 seconds cause such a demand on the body that the heart has to continue to work hard to catch up.
Oh,
and that's
okay.
sort of where the adaptation's coming from.
Huh. So you're gaining a lot of these benefits when you're not even working.
Exactly.
You're sort of ramping up your heart rate, and then it's doing the work.
Yeah, so technically your heart is still working, even when you're just kind of sitting down after the workout.
Yeah. Interesting. Okay, so this might be a good spot to throw on our commercial, and we will be back in 30 seconds.
Well, I was told that I could listen to the radio at a reasonable volume.
There are simply too many notes. That's all. Just cut a few and it'll be perfect.
By the powers vested in me by the Federal Communications Commission, I command you to get on the microphone in a serious manner and continue this broadcast.
93.3 CFMU, seriously redefining radio for over 30 years.
This is my boomstick!
All right, 30 seconds. That was fast. We're back. So, we heard about the research that Billy's doing right now, and you heard earlier that he is a PhD student, but you weren't always at McMaster. Do you want to maybe tell us where you came from and how you ended up here?
Yeah, so I did my undergraduate degree at the University of Guelph, and throughout most of that degree, I had no idea what I wanted to do. It wasn't until 4th year when I took an exercise physiology class that I said, hey, this stuff's really cool. I want to pursue this further. So I ended up going to Queen's then for my master's. I'm from Kingston originally, so it provided me an opportunity to live at home and save some money. So I did my master's in exercise physiology, similar to what I'm doing now, and I went and worked after. So this is a little bit of a unique transition. People typically go from a master's to a PhD, or they go from a master's to work and they continue to work. So I spent a couple years working at, I guess, what you could call a real job, not a student part-time kind of job. So I got exposed to that, and it took 8 months to find an actual job, which was surprising to me. It's like, I have a master's, like, where's all the work? But I eventually found it and was there for a couple years, and just I really missed, 1, science, and 2, exercise. These are my things, and I wasn't doing this in the job I was at. So my decisions were, I can pursue a job in science, preferably related to exercise, or I could do a PhD, which I decided would prepare me really well for that kind of job. I was very cognizant about not just doing a PhD because I didn't know what else to do. You really want to do a PhD because you think it's going to lead you to where you want to go. And I think I want to eventually work in the industry doing some kind of knowledge translation. So you think of companies like, let's use Apple as an example. They put a lot of money into their Apple Watch, and Fitbit and all these other companies do the same thing. They need people who can interpret scientific literature and help them to work it into their product. So that's the kind of place that I see myself going, and a PhD sets you up really well for that.
Okay. Actually, this reminds me of a listener question that we had from a couple of weeks ago when we were talking about VO2 max. The guy I was talking to has a Garmin watch, one of those expensive GPS, etc.
Yep.
And it gives him a VO2 max score after workouts.
Yeah.
And after hearing about what actually goes into your VO2 max score, and this is a scientist, he's like, how could the watch actually measure that?
Yeah.
Like, well, it doesn't, but it sort of models it. So what kind of parameters do you? I mean, you don't know their exact algorithms and stuff, but if you were to guess, what kind of parameters would the watch use to sort of calculate that? Yeah,
a very common one. It'll take your demographic factors into account, so age and sex and things like that. The primary one is heart rate. So it knows your resting heart rate because it can measure it, and then it'll typically have you do some form of exercise. So you go for a run, and then it kind of measures your heart rate, and it can track you via GPS. So it knows your speed and your heart rate. So the quicker you're running, at a lower relative heart rate, or let's say for a given speed, if your heart rate's lower, it's indicative of a greater VO2 max, a higher fitness. So like you mentioned, it has all these algorithms from big population data sets, and it uses that to spit out a value of VO2 max. Now, right now, they're not super accurate. They're okay, but with where technology is going, they're going to get more accurate. And there's actually a very huge application for this kind of watch. I don't know if you want to get into it right now.
Well, I sort of cut you off with your career trajectory because I just got excited that I could answer Kari's question. Hi, Kari. But yeah, that is actually pretty interesting. But before we dive a little bit more into watch stuff, I just wanted to mention that it seemed like, well, first off, it's really cool that you got out of academia and then came back in out of passion. I think that's like really putting you on the right track to doing what you want to do. I know a lot of people do get sort of swept into just continuing on because they don't know what else to do. And it's cool that you had like a good vision of what gets you excited. So you were saying that in your undergrad, you sort of got turned on to physiology because you liked endurance sport already and were just sort of interested in that?
So, I took a course and it was really interesting. And it's funny because most people for a good reason, assume that I like exercise physiology because I have my, big part of my personal life was devoted towards endurance racing, like running and triathlon, and still quite a bit of it is. But funny enough, I don't think that's what actually sparked my passion for it, because the course I was taking was really talking a lot about how exercise can help various conditions like diabetes, for example. Exercise is really, really effective as a preventative measure and even a treatment for things like diabetes. So that really sparked my interest, and sort of my master's lab was a little bit more on the clinical exercise physiology side. So funny enough, like as much as you would think those two things would be connected, my personal athletic pursuits and my exercise physiology academic pursuits, I don't think they are. I think it's just a genuine interest in what exercise can do to the body. Because if you think about it, it's so different, sort of the athletic side of it and then the clinical side of it. It's two very different sort of systems and forms of exercise. So
that makes sense from listening to what you're working on now. It's very much for the average person, it sounds like, and not the Olympian or something like that. And I guess maybe this brings us right back to the watch application. So you're saying that there's some clinical applications to being able to, create these models that are predictive of certain things. Can you maybe dive back into that?
Yeah. So if we had to pick sort of the number one goal of exercise physiologists right now, it is to get cardiorespiratory fitness, or VO2 max, measured in clinic. The reason for this is because it is really effectively, it's a very strong predictor of cardiovascular disease, other chronic conditions, and all-cause mortality, because it has such a, it's so related to how the heart functions. So the American Heart Association, it was actually this paper was led by my master's supervisor. It was a call for making fitness, we'll call it fitness from here on out, cardiorespiratory fitness, a vital sign. So something that is regularly measured in clinic. Now, you say that to physicians and nurses, and they say, how are we going to get a metabolic cart and a bike and have my patients do a 15-minute maximal test every visit? It's not feasible.
Yeah, actually, do you want to quickly explain the protocol for measuring VO2 max typically?
Yeah, so the best way to do it is it's a ramp test to exhaustion. So it's on a bike or a treadmill, usually a bike. When you start at a nice, easy intensity, about 50 watts, and then it'll slowly get harder, and you go until you can't go anymore. The whole time you're wearing this weird mask, and it's collecting what you're breathing out into this expensive metabolic cart, and it spits out a VO2 max, or how much oxygen you're consuming when you hit your maximal amount of exercise. So those carts are expensive. It takes specialized training to run these tests. It can maybe be a little dangerous depending on who the patient is.
Certainly if you're talking about like a somebody who has heart health problems.
And they're maybe the ones who need to know their fitness the best, right? Because if it's predictive of heart health and even when you might die, it's important to know it for them. So alternative ways of measuring this are quite important.
Wow, yeah. I guess it would be interesting to see what kind of data that Garmin uses to actually do these predictions. I'm sure, I mean, you mentioned a lot of the different stuff. It would be cool to get access to all of this big data that they have.
Yeah.
I wonder if they're going to turn into like a 23andMe situation where they monetize all of the data. Have you heard this? 23andMe?
I've heard bits and pieces of it, but
okay. They created this drug and then they sold it to a Spanish company to do clinical testing on it, just off of the people's data that they've collected, which is really powerful. It'd be nice if everybody shared all this data and stuff.
Yeah. No, I think the companies are going to keep it for themselves so they can use it like in their product, unfortunately. But yeah, so sort of the ideal end goal that I kind of see happening with the marriage of technology and health in relation to exercise physiology is a watch or something like that. You know, you have to take socio-demographic status into account. Not everybody can afford one of these watches, but something like that can pretty accurately measure your fitness. And then there's a whole other set of challenges to what I'm about to say in regards to privacy and security. But having that score uploaded to your electronic health record or your electronic medical record, so your physician, when you go for your appointment, they have it automatically and they say, your cardiorespiratory fitness is this, it puts you in this risk category, you know, here are some potential exercises that we can do or a referral we can make. So it really, really tells them what their health status is. And it's a better predictor than blood pressure and even blood sugar. It's a very excellent predictor. So being able to have such a readily available measure of your patient's fitness, I think, can really make a big difference in the healthcare system.
Yeah, that makes a lot of sense. So at its simplest, what do you think you would have to measure consistently to get that kind of stuff? Would you have to do micro blood tests or something like that?
You'd want it to be as non-invasive as possible. So I think we're on the right track with things like heart rate and heart rate variability. But it's just possibly going to take more accurate algorithms, so maybe bigger data sets, maybe like you say, these companies sharing their information and trying to figure this out together. I'm not exactly sure, but as with any kind of technology, things are moving forward at a crazy rate. So 10 years, the sky's the limit, right? We might be able to predict it very accurately.
So the kind of studies that you do, you are taking these VO2 max numbers as a response to different stimulus that you put people under. Could the data that you get also help with pinning down like a non-invasive, maybe like empirical way of measuring VO2 max? Is that kind of the direction you're hoping to go, or? Not
so much. So sort of my master's was more focused on the cardiorespiratory fitness side of it. This is more focused on the exercise side of it. And we already know through this kind of exercise you can improve VO2 max. So now it's more about making it really practical. So the study I was telling you about that I was doing, 3 by 20 seconds, really, really hard on a bike, it sounds very easy and practical. It's not. You need a Velotron, an expensive bike. You need a special software program to sort of run this protocol. So as practical as I'm saying it is, it kind of isn't. It's a laboratory thing, right? So sort of the next steps that I'll be pursuing with my PhD are, what are some practical forms of exercise that we can do? Our lab has done one already before I got there on stair climbing.
I thought I just saw something like that in my news feed.
Yeah.
So stair climbing is intense, right?
Yeah. So the idea is you sprint up the stairs as quickly as you can for 20 seconds. So it's the same kind of stimulus. You could also replicate it sprinting up a hill. Something that is becoming really... people are becoming very interested in is body weight style circuit exercise. So like a minute of jumping jacks, as many as you can, squat jumps, things like that. The idea being that this is something anybody can do. You can do it in your kitchen, right? You don't need specialized software. And not only might this improve your fitness, it might improve things like your muscular health, its strength, and your ability to just perform tasks of daily living. So that's kind of where I see the PhD going, is like, now that we know this kind of exercise is helpful, how can we make it really practical for people?
Yeah. I guess maybe like a takeaway that listeners can have here is that you don't necessarily have to have the exact protocol of, 30 seconds on, 5 minutes off, et cetera, et cetera. As long as you feel your heart is still working in between these intervals, is that sort of a good tell that you're on the right track?
You're exactly right. It's a continuum. And I've talked a lot about interval training and how amazing it is. But truth is, it's as good as the moderate intensity training. So if you prefer to do a 45-minute sort of jog or something like that, it's just as good doing that. And anything in between. So I've talked about the extreme because it's interesting measuring extreme. So the extreme, what's the lowest amount you can do? And you have to go really hard, but there is in between. So you can go maybe 15 minutes at like a somewhat hard intensity, as you were saying. It's definitely a continuum. So the take home I would say is if you want to exercise light, you have to go longer. If you want to make your exercise short, then you got to go hard.
Right. Okay. And that, I guess, allows people who can't necessarily get their heart rate super high due to, physical reasons, if they're older or something like that, they're not left out. They can still do exercises. It just won't be as efficient.
Well, and that's the beauty of interval training, and a bit of a misconception that you have to really just go nuts and during your interval. It's relative, right? So our department has done research, one of my colleagues, on interval training in cardiac rehabilitation. So people with very low exercise capacity, and their intervals look more like, brisk-ish walking interspersed with like rest or really slow walking.
Okay.
And that's still interval training because their heart rate still gets high relative to their max heart rate. So it's about what is relative for you. So an athlete doing an interval workout versus someone in a cardiac rehabilitation program doing one is going to look very different in absolute terms of speed or in wattage being put out. But in relative intensities, they're working the same amount.
Huh. Yeah, I never thought about it like that. That makes a lot of sense. You want that delta.
Exactly, yeah.
to be high. So we're running out of time. So maybe if listeners are interested in hearing more about this stuff, are you on social media? Do you have a website or something that you can direct people to?
Yeah, I post sometimes on Twitter and Instagram. Not as often as I'd like to, but I'm available on there. It's I talk about my research sometimes my personal life, like what I was doing on the weekend. But feel free to give me a follow, and I don't know if you have my email or if it's, if you can post it somewhere, but if anybody has any questions about this stuff or possible collaborations or, anything like that, then feel free to send me an email.
Yeah, that's actually a nice tip. Your lab is often looking for students. Is that true?
Kind of, yeah.
You're not personally hiring them, but
yeah, like we're always looking, especially outside perspectives too. So if anybody from one of the a medical type of study or schooling wants to come and chat about how to make this stuff more practical, we're always open to some kind of collaboration. We can't guarantee there's going to be a spot or we'll have the time to do it, but always open to an email.
And are you ever looking for people to volunteer as subjects in your studies?
Always, yeah.
Okay.
I don't know if the ethics board wants me to recruit through the radio, but if anybody's interested in doing any of this kind of stuff, chances are we'll have a study going on within
and they can
email
months. You and ask if there's anything coming up or anything like that.
Yeah.
Could be a good opportunity to get some tubes put in your mouth. And,
tubes put in your mouth. Yeah.
Cool. Well, thanks so much for coming on. This was really fun.
Oh, thank you.
Sorry we didn't talk about your triathlon career.
Oh, it's fine. That's in the past anyway.
I really wanted to talk about that, but I don't know. The science is super interesting.
Thanks.
All right, so we are wrapping up the AlmaMAC for this week, and Get Lit is starting shortly, so stick around. Here comes.